Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Fazli Anan. You can call me Fazli. And my NPM is 23312072. Alright, today I will explain about the basic of algorithm concept. Alright, an algorithm is a well-defined finite sequence of steps or instruction designed to solve a particular problem or perform a specific task. To be considered an algorithm, it must possess certain fundamental characteristics. Finiteness means the algorithm shall always terminate after a finite number of steps. Definiteness ensures that each step is clearly defined and unambiguous, so that the process is straightforward and can be followed without confusion. Every algorithm must also have an input, which is the data provided to the algorithm to operate on, and it should produce at least an output that represents the solution to the problem or the result of the task. The effectiveness of an algorithm indicated that each operation or step must be basic enough that I can be performed in principle by a person with pencil and paper in a reasonable amount of time. Algorithms can be represented in various ways, such as pseudocode which describe the step in high level, human readable format that closely resembles a programming language but without rigid syntax. This allows for a clear conceptual understanding of the process. Another common representation is a flow chart, which use symbol and arrow to visually depict the flow of control through the algorithm, illustrating decision point, loops, and the sequence of operation. Algorithms can take different forms depending on the structure of their logic. Sequential algorithms follow a straight path where each instruction is executed one after the another in a fixed order. Conditional algorithms introduce decision making where different branches of the algorithm are taken depending on the outcome of certain condition. This is typical implemented using if-else structure. Alternative algorithms use repetition, looping over a step multiple times, often using for or while loops. Recursive algorithms are more they involve the algorithm calling itself to solve smaller sub-problems until a best case is reached, as seen in problems like calculating the factorial of a number or solving the Tower of Hanoi. There are several key design techniques used in algorithm development. Divide and conquer involves breaking a large problem into smaller, more manageable sub-problems, solving each one independently, and then combining the result to solve the original problem. Examples of this include the Murex port and binary search algorithms. Greedy algorithms focus on making the locally optimal choice at each step with the hope that this local solution will lead to the globally optimal solution. This approach is used in problems like finding the minimum spanning tree with Kruskal algorithm. Dynamic programming is another technique that solves problems by breaking them into overlapping subproblems. Solving each subproblem once and storing its solution to avoid redundant calculation, such as in the Fibonacci sequence calculation. Backtracking involves trying different possibilities and using steps when a solution path is found to be incorrect. Often used in solving puzzles or problems like the n queens problem or maze solving. The efficiency of an algorithm is crucial, especially when dealing with large data set or time-sensitive application. Efficiency is measured primarily in terms of time exam complexity and space complexity. Time complexity refers to the amount of time an algorithm takes to complete as a function of the input size, commonly expressed using big O notation, which provides an upper bound on the growth rate of the time required. Space complexity measures the amount of memory an algorithm requires. Relative to the input size, understanding these complexities is essential to choosing that right algorithm for a given task, particularly in scenarios where performance is critical. In summary, algorithms are the core of problem solving in computing, providing a structured approach to breaking down and resolving complex tasks. By understanding how to design, analyze, and apply algorithms, one can create more efficient, effective, and optimized solutions to a wide variety of problems. Thank you. That's all from me. I thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.